Hi everyone. In this very short flash talk, I would like to introduce a key feature in NetMiner 4.0 and say a few words about the new NetSpace platform that we've been developing over the last year. NetMiner stands for Knowledge Network Miner and is a set of tools and resources developed in designing future Weed Work Package 4 to support gene discovery and complex trait analysis in Work Packages 1, 2, and 3. So how does NetMiner work? First, we work with data providers to identify relevant, high quality and fair datasets that can add value to gene discovery. We then use the NetBuilder software to transform and integrate the data into an intelligent data model that we call a knowledge graph. A knowledge graph consists of concepts and relationships. Concepts can be genes, proteins, traits, publications, and the relationships between them can be differentially expressed, associated ways, encodes, interacts ways, and so on. The weed knowledge graph has been constantly growing over the past few years. Currently, it has over 40 datasets with information about 110,000 weed genes. In total, it contains 750,000 concepts and 4 million relationships. The data is open access and can be accessed through different means such as RDF, Neo4j endpoints. Here I'm going to talk about the NetMiner user interface and the new features it has. All public NetMiner resources, including Weed, Arabidopsis, and Rice, have been updated to the latest 4.0 release. It comes with user workspaces, a space for users to save, edit, and share gene networks generated by NetMiner. Let me give you a quick tour of the new features. This is a NetMiner resource for Weed. It provides a user-friendly and efficient interface to search a large knowledge graph for a list of genes that could come from a differential gene expression study, for example, in combination with optional keywords that can be trait or disease related. In this example, we're searching for a large list of genes in combination with keywords such as dormancy or germination or color or flavonoid or proanthocyanidin. So NetMiner tries to identify biologically plausible evidence in the knowledge graph that can relate these candidate genes to any of these keywords. Pressing search provides the user with a ranked list of candidate genes and summarizes the evidence in this column here. So now the user usually selects one or multiple genes to explore the full evidence in a network view. Okay, so in this example I have selected two genes, PDH and STY8, with a set of keywords that were disease related. And NetMiner has generated automatically this gene knowledge network for me. As you can see, it's got a lot of information that users usually go through one by one. They look at the different pieces of evidence by clicking on the relationships and studying the information provided in this info box, or on concepts and reading the publications. For example, in this case it's a paper from 2016, and deciding if the evidence that NetMiner automatically generated is plausible. If not, they might hide that information. They might work with the interactive legend at the bottom to add more information to the network. They can relay out the information, the network, add labels to the nodes, and so on. So sometimes users spend a long time, maybe 20 minutes or half an hour, exploring these networks. So in the past, once they were happy with the discovery they had made, they would take a screenshot of this view and send it to a collaborator, or they would write up some of the findings and try to explain it in a very lengthy email to a colleague. But now in NetMiner 4.0, there is a new safe network button at the top right corner. Pressing this button brings up a little dialog that allows the end user to provide a name for the network and a short description. Once they click the Save button, the network gets automatically uploaded with a bit of metadata and all visual layout information to the user's workspace, which we also call NetSpace. Okay, so here we are. This is my NetSpace. It shows the list of networks that I have been working on in the past. As you can see on the top left corner, there is a DFW All Hands demo network that I just saved into my NetSpace. I can now click on a specific network and it shows me some information and metadata about the network, such as the name, description, and the owner, which genes were used to generate the network in combination with which keywords, for example, rust or response or disease in this case, which NetMiner application generated it, where it is hosted, how large the network is, which database version it's based on, when it was modified, and it provides me a link that I can share with colleagues. So now I can, for example, share this network either using this link, or I can share it directly with other NetSpace users by clicking this button here. And it provides me a simple interface where I can add specific users and give them permission, edit or view permission to the network. So I have shared this network yesterday with a few people that are today in the audience. So you should all have access to it. This is a really great feature if our groups want to work collaboratively, for example, on curating networks, and for publishing networks in publications by providing the link into your manuscripts. Okay, to summarize, NetSpace is our new platform that allows users to manage the networks that NetMiner generates and allows you to share the stories of genes, traits, and diseases with our colleagues. Since its launch in June, we had over 100 registered users that are using the platform already. So a big thank you to all beta testers for providing feedback and all the fair data providers. There are free and paid subscription plans for NetSpace, and I'm happy to say that all DFW members will get the Pro plan for free. So the next release of NetMiner NetSpace is scheduled for 2021. If you've got any feature requests, please let us know, and I would encourage you to sign up today to the platform. So finally, I would like to say a big thank you to the NetMiner team who has worked really hard to make all this possible. I'd like to thank Ajit Singh for maintaining all the live instances of NetMiner and working on the different front-end features. I'd like to thank Marco Brandisi for working on the NetMiner backend and all the fair technologies to make our data more accessible. A big thank you to our recent starter, Jeremy Parsons, who is helping us to build the knowledge graphs and keep them up to date, and Joe, who has worked in the past with us but has recently left Brosmsted. Also like to thank Dan, who worked in collaboration with Kim and Joe to build NetMiners for fungal pathogens such as Fusarium culmorum, and of course Chris Rawlings for all his scientific advice. Thank you for listening.